Hello everyone. So in this video we are going to derive the formulas for some physical quantities using dimensional analysis. So in our first example we are going to derive the time period for a simple pendulum using dimensional analysis. And it is known that the time period of pendulum of a simple pendulum t which may depend on mass of the bob m, length of the thread l, and acceleration due to gravity g. Okay, so let this time period t is proportional to up to some power of m, l, and g, that is t proportional to m to the power a, l to the power b, and g to the power c. So altogether we can write t is proportional to m to the power a, l to the power b, and g to the power c. So this will be equals to t is equals to k m to the power a, l to the power b, g to the power c, where k is the dimensional constant. So this is our first equation. Now we can write the dimensional formulas for the various physical quantities, that is m, l, and g, and for t also, as t represents the time period. So it will have the dimension of time only. M will have m to the power a, and l is the length, which is capital L, and g is the acceleration due to gravity. So its dimensional formula is l t to the power minus 2, and a, b, c are their corresponding powers. Okay, so again we can write the left hand side as m to the power 0, l to the power 0, t to the power 1. So m to the power 0, l to the power 0 will going to give you 1. So that's why I don't write it in the previous line. So but you can write it like this. Okay, one thing I'd like to mention that k is dimensional constant, so I did not consider k in these expressions. Okay, so now I just wrote the similar quantities all together, that is m to the power a, l to the power b plus c. So in the second term the power of l is b, and in the third term power of l is c. So it gives you l to the power b plus c, and the third term is l to the power t to the power minus 2 power c. So it is t to the power minus 2c. Now, comparing similar quantities or dimension of similar quantities, we can write that. So as you can see in the left hand side, the power of m is 0, and in the right hand side, the power of m is a. So a must be equals to 0, and similarly b plus c will also will be 0, and minus 2c will be equals to 1. So these are the three equations. Okay, and we need to solve these three equations to find three constants, that is three powers, that is a, b, c. Okay, so from the third equation minus 2c equals to 1, we can say that c is equals to minus half. And if you put c in the second equation, then we can write that b is equals to minus c, which is minus of minus half. Therefore b is equals to half, and from the first equation we already have a is equals to 0. So if you put these three values of a, b, c in the equation 1, then we can write t is equals to k into m to the power 0, l to the power half, g to the power minus half. Okay, as the equation is m to the power a, l to the power b, g to the power c, so we are only putting the values of a, b, c. Therefore we can write t is equals to k to the power root over l by g. So okay, so using dimensional analysis we can't we can determine the value of k, this dimensionless constant, but in real life case the value of k is 1 over 2 pi. So the actual expression for the time period for this simple pendulum is 1 over 2 pi root over l by g. Okay, so now let's consider another example. Frequency of a straight string using dimensional analysis, and it is known that this frequency depends on the length of the string, the mass per unit length of the string, and the tension on the string. Okay, so let the frequency is n, and n is proportional to up to some power of these three quantities, that is n is proportional to t to the power a, proportional to l to the power b, and m to the power c. So altogether n is equal proportional to t to the power a, l to the power b, and m to the power c, or we can write n is equals to k times t to the power a, l to the power b, m to the power c, where k is dimensionless constant. Okay, so this is our equation 1. Now n represents frequency, which is 1 over time period. Okay, therefore dimension of m must be equals to time inverse, that is t inverse. Therefore the left hand side, the dimension of the left hand side must be m to the power 0, l to the power 0, t to the power minus 1. So that is m to the power 0 is 1, l to the power 0 is also 1, so it is only t to the power minus 1. But for simplicity, we can write it like this. Now in the right hand side, we have T, L and M. So T represents tension or force. So the dimension of tension must be equals to force, that is ml t to the power minus 2, and L to the power b, and ml inverse, that is small m, that represents mass per unit length, that is total mass by total length. That's why I wrote it ml inverse, that is m by l. So now collect all the similar quantities. So that is m to the power a plus c, l to the power a plus b minus c, and t to the power minus a. Okay. So now we are going to compare the dimensions of similar physical quantities, and then we will get a plus c by comparing the first term, that is the m, power of m. So in the left hand side it is 0, and in the right hand side it is a plus c. So a plus c must be equals to 0. So similarly, if we compare l and t, then we will have a plus b minus c equals to 0, and minus 2a is equals to minus 1. So these are our 3 equations, and we need to solve this to determine the values of ABC. So from equation 4, we can say that the dimension, the value of A must be equals to half. So if you put this value of A in the equation 2, then C will be minus A, and which is equals, C is equals to minus half. And if you put this in 3, then we can write B is equals to C minus A, which is equals to minus half, which is equals to minus 1. So A is equals to half, C is equals to minus half, and B is equals to minus 1. So if you put these 3 values into equation 1, then we can write N is equals to K times T to the power half, L to the power minus 1, M to the power minus half, or K is equals to K by L over T by M, or in general the value of K is half. So it is the actual expression for the frequency of a straight string is 1 over 12 root over T by M. So this is the actual expression. Okay, so let's solve another example. So it is known that, this is a question, it is known that the time of revolution t of a satellite around the earth depends on the universal gravitational constant capital G, the mass of the earth capital M, and the radius of the circular orbit r. Obtain an expression for capital T using dimensional analysis. So let the time period capital T depends on up to some power of G, M, and the r, radius of the circular orbit, up to some power, say ABC. Okay, so G to the power A, M to the power B, and R to the power C. So we need to find this A, B, C. Okay, so T is equals to K times G to the power A, M to the power B, R to the power C, where K is the dimensionless constant. So this is our first equation. So in the left hand side, we can write the dimension of T is m0, L to the power 0, T to the power 1. That is, it has only the dimension of time. So the mass and length, dimension of mass and length part is 0. So in the right hand side, it is the dimension of G is m inverse L cube T to the power minus 2. We already derived this the dimension of universal gravitational constant G in a previous video, so you can check that. So the second term is mass, so m to the power B, and R represents length, so L to the power C. Now collecting similar quantities, so m to the power minus A plus B, L to the power 3A plus C, and T to the power minus 2A. Okay, now we need to compare similar quantities. So the first term is mass term, so in the left hand side it is 0, and in the right hand side the power of m is minus a plus b. Therefore minus a plus b must be equals to 0. And similarly for other two terms, 3a plus c must be equals to 0. That is comparing the length term. And if we compare the time, so minus 2a must be equals to 1. So these are our three equations, and we need to solve this to find these three variables a, b, c. So from equation 4 we can say that a must be equals to minus half. So if we put it in equation 2, then we can say that b is equals to a, which is also equals to minus half. Now from equation 3 it is c is equals to minus 3a, so it is equals to 3 by 2. Okay, now if we put these three values into equation 1, then we will have t is equals to k g to the power minus half m to the power minus half r to the power 3 by 2, or we can write it like this, k r cube by gm. So this is the formula for time period using dimensional analysis, but in general t is equals to 2 pi root over r cube by gm. So this value, the actual value of k is 2 pi, this dimensionless constant. So as you can see, there is a limitation using this dimensional analysis, that we can't determine the value of this dimensionless constant using this procedure. So this is the limitation. Also we can't determine a relationship between physical quantities if some physical quantity depends on more than three quantities. So these there are few more limitations of dimensional analysis.